everybody. Josh Rappaport here with Now I Get It Math. Today I'm really excited to present my second in the series of common algebra mistakes. And the mistake I'd like to explore today involves this little expression, x times x. Those of you who are instructors know that students often think that this equals, guess what? 2x. Okay, and let's take a moment for what I always like to call a moment of empathy. So to have a little empathy for students, let's just pay attention to the fact that there is a certain level of logic in thinking that x times x might equal 2 times x, which involves the following. Both sides of our equation here have multiplication. The left side has 2 x's. The right side has an x and a 2. So in some sense, both sides of the equation are very similar. The problem, though, is that there's a deep logical flaw in one's reasoning and thinking they're equal. Now, we want to find what the flaw is, so that's what we're going to do is play Find the Flaw. When I tutor students, I find that their reasoning, if I prod a little bit, usually boils down to 3 steps, which are like this. First, V for variable. Variables are weird. They're like numbers. This is students talking, of course. They're like numbers, but they work differently than numbers. Step 2 in students' thoughts. I don't really get how variables work, but my guesses are right about 50% of the time. So, may as well guess. Step number 3, x times x has 2 x's, so the answer is probably 2x. So we'll put down 2x. Okay, now, where is the flaw? Where is the flaw in that reasoning? Everybody go ahead and take a guess. Is it step 1, step 2, step 3 where the primary flaw is? And I'll tell you where I think it is. I think the biggest flaw is in step 1. Why? Because of this little step right here, where students say that variables work differently than numbers. Because in fact, that's not true. Variables actually work exactly like numbers. And this is a super important point that we as educators want to make. Whatever is true about how numbers work, if we apply that to variables, we'll see that's exactly how variables work. And we can use that to our advantage as educators, and once we teach students how to do that, they can use that to understand how variable expressions work. It's a great, great strategy when explaining algebraic expressions. So let's show how this works right now. Okay, so what we do is we say to a student who thinks that x times x might be 2 times x, we say, let's just take that right here. Let's explore that. X times x equals 2 times x. And what I like to do is I put a little question mark over the equal sign to say, is it in fact true? We want to know if that's true. And then we'll say, well, let's let x equal 3. We'll pick a number, and we'll choose 3, and we're going to substitute in 3 for x. So we put a 3 for the first x, a 3 for the second x, and a 3 for the last x. And then what do we get? We get 3 times 3, question mark equals 2 times 3. 3 times 3 we know is 9. 2 times 3 we know is 6. Oh, look at that. 9 is not equal to 6. So those two are not equal. Therefore, the result is that 3 times 3 is not equal to 2 times 3. Now, that's actually all it takes to show that this is not true. All it takes is one counterexample, because for this to be true, it has to work for every single example of x. Okay? So right there, it's false. But sometimes students like to see things done a few times, so let's do it another time. Let's let x equal 10. Okay, then again, we've got x times x, question mark equals 2 times x. Substitute in 10 for the x's, for that x, for that x, and for that x. Now we've got 10 times 10. Does it equal 2 times 10? 10 times 10 we know is 100. And 2 times 10 is merely 20. Uh-oh, 100 is not equal to 20. So therefore, 10 times 10 is not equal to 2 times 10. Now here's kind of the cool part. In the same way that we substituted 3 for x, we can do what I call reverse substitution right here. We can substitute x back in for 10. If two things are equal, you can substitute either way, can't you? So what we're going to do is we're going to substitute x for 10 right here in this line. And we're going to say that means that x times x is not equal to 2 times x. So that right there shows x times x is not equal to 2 times x. So we go to our rule here and say it's not true. Well, that's nice and it's very helpful. But there's still something that's going to be a little bit lacking in students' understanding as to why this is true. And what's understanding is what I call the big why, is still kind of missing. So let's explore that a little bit. So here's how I like to think about it. I like to go back to the numbers to help students understand it, because after all, students who are doing pre-algebra, algebra, this kind of level of math are still coming from the warm, cuddly world of numbers. And the world of variables is still kind of a cold, unfriendly place. So let's let them use the world they're used to, the world of numbers. So what we'll say is, okay, let's explore x times x. We saw that if x is 10, that's 10 times 10, which is 100. So clearly, with x times x, the numbers are just multiplying themselves, each other. So we have 10 times 10. The two x's there are just multiplying each other. We have x times x. Okay, now, here's the interesting part, because that part's fairly obvious. The interesting part is that with 2x, okay, the right side, that would be like 2 times 10 if x is 10. Well, 2 times 10 is just 20. And 2 times 10 really means two groups of 10, which after all just means 10 plus 10. Oh my gosh, 10 plus 10. That really just means that 10 is being added to itself, not multiplied, but added. So we have two x's here, but they are added to each other. So 2x really means x plus x, right? So we can summarize this by showing how these two expressions are different, the expressions on either side of the equation. So pardon me while I do a little erasing. As we've seen, these two expressions are in fact not equal. And here's the way to understand it. X times x means the x's are multiplying each other. So what we really have there on the left side is x squared. That, after all, is just the definition of x squared. It's x times x. On the right side, we have 2x, which actually equals x plus x. So this is an expression where the x's are multiplying each other. And this is an expression where the x's are in fact being added to each other. And that's why the expressions are entirely different. Okay, so to summarize, I've explained a really nice strategy for helping students learn how to understand and decode and kind of analyze variable expressions, which I like to summarize with this little math moral here. To learn how variable expressions work, we can plug in actual numbers for the variables and analyze the value of the answer. And that's what we've done. And before we finish this, I want to just say there is one little caveat, one little warning students need to know before they use this strategy whenever they feel like it. And I'm going to explain that in the next section. So now I want to present the one warning you need to know about the strategy I just presented. Okay, so the warning is when you're using this plug-in strategy, substituting numbers for the variable to find out the value of the variable expression, there are a few numbers that can provide unreliable results. Let me give you an example. Let's say your hunch with the previous example is that x times x is 2 times x, as we said, and suppose that your plug-in is that you let x equal 2. Watch what happens. Then you'd have x times x equals 2 times x. You plug in 2 for x, and you get 2 times 2 equals 2 times 2. Well, that means that 4 equals 4, which is true. So you'd be getting an answer that says that x times x is in fact 2 times x, and we know that that is not true. So the moral right there is don't use 2. 2 can be problematic as your plug-in. Let's look at another example. Let's say you're exploring whether or not it's true that x to the y equals y to the x, basically flipping the bases and the exponents, okay? And let's say that you're going to let x equal 2 and y equal 4. Well, when you substitute, you would have 2 to the 4th equals 4 to the 2nd. Well, what are the values of those? 2 to the 4th is 16. 4 to the 2nd is also 16. You'd be getting that 16 equals 16, and you might think, if you weren't any more careful, you might think, oh, that proves that x to the y is y to the x. But if you just run a second test, letting x be 2 and y be 3, you would see that 2 to the 3rd is being checked for being equal to 3 to the 2nd. 2 to the 3rd is 8. 3 to the second is 9, 8 is not equal to 9. So when you run your second test, you'd see that in fact x to the y is not equal to y to the x in this second case. And all it takes is a second case, one case where it doesn't work, to prove that the rule is false. Okay, so all it takes is this one, it's called counterexample, to show that this whole thing is false. Even though it worked once, doesn't mean it's true. It just means that this was some weird, freakish coincidence where it happened to work. So how do we get students to avoid this problem? How do we get them to really heed this warning? What I suggest is a two-step solution. We teach students to first always run 2 tests. Okay, that's one way, as we saw here. And the other thing is to use numbers such as 3, 5, 6, 7, 8. Notice I'm excluding 4. I'm excluding these numbers here, 2, 1, 0, -1. Those numbers can sometimes play out to give you weird results, and we don't want weird results that lead to conclusions that are not true in general. So as long as students follow these 2 steps, they should be just fine. So I hope that helps everyone understand why x times x is not equal to 2x. And more generally, I hope it helps everyone get a really nice strategy for evaluating variable expressions. And to help everyone get an even firmer handle on that, I'm going to put up a few examples of variable expressions that you can get the value of using this very strategy of plugging in numbers. So that will follow this video. And as always, thanks very much for watching, and see you in the next video.